Good morning. Today we are starting our first objective in our third binder. This is PO 46. I can create a function table for a given equation. So in order to do a function table, we need to know what all the parts of a function table are about. There will be an input, and that is what you plug into an equation. And it's what is being tested. Then we have our output. The output is the result of the equation or test. We call our input the X and the output the Y. On a function table, or what a function table is it's a way to organize multiple inputs and outputs to get ordered pairs for a graph. So before Christmas, we were working on graphing. We were working on those ordered pairs, giving us a review of how graphing works with our x-axis going horizontal, the y-axis going vertically. We're going to be working with those graphs now. We're going to use function tables to help us to graph. So we're going to be doing a lot with the function tables and with graphing in this unit. The equation we get from a function table is known as the rule of the table. So if you're going in order, if you're putting in 1, 2, 3, 4, you'll be able to see the pattern for the y's. So if your x's are going in order, your y's are going to go in order, and you'll see patterns forming. We create a function table with at least 4 inputs and outputs for each equation given. We need 4 to find the pattern. Remember, you can choose the inputs for your table, and we want to choose smart ones. And I'm going to show you what it means to choose a smart input. So let me scroll up. So if we want to make a function table for y equals x plus 3, I'm going to make my table like this. I'm going to put x always goes on the left, y always goes on the right, just like with ordered pairs. The x is the input. We get to choose it. What do we want to put in? I like to choose easy ones. I need to have 4 inputs. My brain likes to go to 1, 2, 3, 4. So if I put a 1 in for my x, what is my y going to be? Probably 4, because I have to do the math. 1 plus 3 is 4. So my next input is 2. 2 plus 3 is 5. And then I put in the 3. 3 plus 3 is 6. I put in the 4. 4 plus 3 is 7. So if I'm doing 1, 2, 3, 4, I can see that pattern and how it's going to increase. Can anybody see what the rule would be for this table? Come on. You're plus adding 3 to the input. Okay. So, let's look at this one. Do I have to do 1, 2, 3, 4? I can do 100, I can do 150, I can do 2013, I could do 1,000,002. You can do whatever X you want. Do I want to get complicated with it? No. Because the more complicated we get, the easier it is to make those simple mistakes. Keep it simple. We're not being silly with our pencils, we're paying attention. Alright, so we want to keep things simple. That's why I just stick with the 1, 2, 3, 4s. When I have just multiplying, dividing, adding, subtracting. When we get to this one with the fraction, I'm going to show you a trick. So here, if I do 1, 2, 3, 4, what would my y's be? If I put a 1 in, what is the output for that? Vivi?
-1. Or -2.
-2. Because I have to multiply it by a -2. If I put the 2 in, what do I get? Amala? If I put a 3 in, what do I get? David?
-6.
And if I put the 4 in, what do I get? -8. Now let's look at y equals 5x minus 8. Somebody tell me some different numbers we could use. You don't always have to do 1, 2, 3, 4. What might we do here? Christina? Maybe starting with the 10. 10, 11, 12, 13. So, if I put a 10 in, what is my output going to be? Who can do that math? If I put the 10 into my equation. Claire? 42. What if I put an 11 in? David?
47.
What if I put 12 in? Michael?
52.
And what if I put 13 in? Amala? So if I had put a 1 in, 1, 2, 3, 4, all of a sudden I have 1 times 5 is 5 minus 8. I have to start working with those negative numbers. It's fine if you're comfortable working with negative numbers. If you still get a little thrown off going into the negative numbers, choose bigger numbers. Okay? You can choose the numbers that work well for you. If I put a 2 in, well, I only had the one negative number there then. Alright, but you can choose which numbers you want to use. If you don't want to have to deal with negative numbers, then choose bigger numbers. What number should I choose for this one for my input? David?
17.
Okay, what's 17 squared? So, me personally, again, I like to use numbers that are easy for me to work with. I don't know 17 squared off the top of my head. So, I would choose to do smaller numbers that I can square right away. So what would be a smaller number that we could square right in our heads? Harper? 1. What's 1 squared? 1. What's 1 minus 10? Let's try 2. If I put a 2 in there, what is my answer going to be? 2 times 2 is 4. 4 minus 10 is negative 6. Now if I put a 3 in, Christina? 3 times 3 is 9. 9 minus 10 is negative 1. Now if I did 4. LJ? 4 squared is 16. 16 9 minus 10 is 6. Okay, so be smart with the numbers you're choosing. Okay, if you're gonna square something, don't pick huge numbers that you don't know how to do in your head and make sure that you're doing it right. Pick smaller numbers. Here's the one that we want to really know about. When you're working with a fraction, we want to turn those fractions into whole numbers because it's a whole lot easier when we're adding or subtracting with whole numbers than with fractions. So to do that, we look at what the denominator is, and we're going to do multiples of that denominator. So multiples of 4 are 4, 8, 12, and 16. What's 1/4 of 4? 1. What's 1 plus 7?
8.
What's 1/4 of 8?
2.
2. What's 2 plus 7? What's 1/4 of 12? Baby?
3.
What's 3 plus 7, baby?
10.
What's 1/4 of 16? Amala? And what's 4 plus 7, Amala? It's a lot easier to work with those whole numbers. So when we're multiplying by a fraction, be smart about it. Choose that multiples of your denominator so you can go quickly down to that whole number and then add or subtract it. We are going to come back to this when we come back for lunch. I am still recording, so please keep it quiet. I will make a part 2 after lunch. So stay tuned for part 2.